In this video, we're simplifying radicals. We want to start with a simple rule that the square root of a times b is equal to the square root of a times the square root of b. This is really useful when we're working with something like the quadratic formula because we end up with radicals and we're able to simplify them when we're coming up with exact roots. So let's start with an example. If I had the square root of 75, I can rewrite this as the square root of 25 times 3. And this is the same as the square root of 25 times the square root of 3. And the square root of 25 is a nice number. It's 5. And then root 3. So root 75 is equal to 5 root 3. Let's try another one. If I had the square root of 72, square root of 72 is not a nice number, but I could break this down as the square root of 36 times 2, and this is the same as the square root of 36 times the square root of 2. Square root of 36 is 6, and root 2. So root 72 is equal to 6 root 2. So this is a way that we can simplify radicals. The next thing we want to look at is how to add and subtract expressions that contain radicals. So if I have something like root 5 plus 2 root 5, both of these terms have the same radical parts, so I can just add them together. 1 root 5 plus 2 root 5 gives us 3 root 5. If I'm subtracting, root 7 minus 3 root 7, both of these terms have the same radical part. The root 7 is the same. So if I take 1 root 7 and I subtract 3 root 7s, this gives me negative 2 root 7. If I want to look at how to multiply radicals together, let's start with figuring out what happens when I multiply root 7 by root 7. Using our rule, root 7 times root 7 is the same as root of 7 times 7. And this is the same as the square root of 49. The square root of 49 is 7. So that's kind of an interesting result. When I take the square root of 7 and I multiply it by itself, or I square it, I get back the whole number 7. So that result's going to become very useful. Let's take a look at what happens when we distribute root 5 through root 3 minus 2. So what you're going to do is you're going to multiply the root 5 times each of the terms in the bracket. So root 5 times root 3 gives us root of 5 times 3, or root 15. And root 5 times 2 gives us 2 root 5. I can make this a little bit more complicated. I can recall what happened when I multiplied a binomial times a binomial when I was working with simplifying algebraic expressions. I multiplied the first term in each bracket, the outer terms, the inner terms, and the last terms, and then I collected any like terms together. It's the same idea here, it just involves radicals instead of x's. So root 5 plus 2 times root 5 minus 3. So you're going to start by multiplying the first term in each bracket. Root 5 times root 5 is square root of 25, or 5. The outer terms, root 5 times negative 3 gives me negative 3 root 5. The inner terms give me plus 2 root 5. And the last terms multiplied together gives me minus 6. So now I can collect together the like radical terms. So 5 minus 6 is negative 1, and negative 3 root 5 plus 2 root 5s gives us negative root 5.